You step outside on a clear night, and something feels deeply wrong. The sky is darker than it should be. No gentle silver light bathes the landscape. No bright orb hangs among the stars. Our moon simply isn't there. Without our faithful companion, Earth would be a fundamentally different world. Ocean tides would barely exist, reduced to weak solar tugs. Our planet would wobble chaotically on its axis, creating wild swings between scorching summers and brutal winters. Nights would be pitch black, save for distant starlight. Many scientists believe complex life as we know it might never have evolved at all. But here's the remarkable thing. Our moon almost didn't exist. 4.5 billion years ago, Earth was a violent, molten world still taking shape. Then something extraordinary happened. A Mars-sized planet called Theia came hurtling through space on a collision course with our young world. The impact was so tremendous that it nearly destroyed both planets, launching massive chunks of rock and metal into orbit. From that cosmic catastrophe, our moon slowly coalesced. This isn't just Earth's story, though. Throughout our solar system, moons tell tales of cosmic drama that would make any Hollywood blockbuster seem tame. Some moons were born from the same swirling disks of gas and dust that formed their parent planets, growing up together like cosmic twins. Others are cosmic orphans, asteroids and comets that wandered too close to massive worlds and found themselves permanently trapped by gravity's invisible chains. Jupiter's moon, Europa, hides a vast ocean beneath its icy shell, while Saturn's tiny Enceladus shoots towering geysers of water hundreds of miles into space. Mars hosts two small potato-shaped companions that might be captured asteroids still telling the story of their wandering past. Even stranger, Neptune's largest moon Triton orbits backward, suggesting it was once a free-roaming dwarf planet until Neptune's gravity claimed it as its own. Each moon in our solar system carries the scars and secrets of its formation. Some formed peacefully alongside their planets, others survived violent captures, and a few were literally forged in the fires of planetary collision. Tonight, when you look up at our moon, you're seeing more than just a celestial nightlight. You're witnessing the result of one of the most dramatic events in Earth's history, a cosmic accident that helped shape the world we call home. The story of how moons form isn't just about distant astronomy or ancient history. It's about understanding our place in a universe where chaos and creation dance together, where violent beginnings can lead to beautiful endings, and where every world has its own unique tale of survival against impossible odds. So before we dive deeper into these cosmic origin stories, take a moment to appreciate the incredible journey that brought these silent witnesses into existence. From gentle accretion to catastrophic collision, from gravitational capture to ongoing geological activity, moons are far more than just rocks in space. They're the keepers of solar system secrets, and they're ready to share their stories with anyone curious enough to listen. Let me tell you about one of the most elegant ways moons come into existence. Picture the early solar system as a cosmic construction site, with swirling disks of gas and dust surrounding every growing planet. As these massive worlds pulled material toward themselves, they created their own miniature versions of the original solar system disk. And just like planets formed from the larger disk, moons began taking shape within these smaller spinning clouds of debris. This is exactly what happened around the gas giants Jupiter and Saturn. These massive worlds acted like cosmic vacuum cleaners, gathering so much material that they created entire families of moons. But here's where it gets really fascinating. Some of these moons grew so large that they rival actual planets in size and complexity. Take Ganymede, Jupiter's largest moon, and the biggest moon in our entire solar system. This incredible world is actually larger and more massive than Mercury, the smallest planet orbiting our Sun. Think about that for a moment. If Ganymede were orbiting the Sun instead of Jupiter, we'd call it a planet without hesitation. It has its own magnetic field, layers of ice and rock, and possibly even a hidden ocean beneath its surface. Then there's Titan, Saturn's largest moon, which is almost as big as Mars and has a thick atmosphere denser than Earth's. Titan has lakes and rivers, weather patterns, and seasons just like a planet. The only difference is that its lakes are filled with liquid methane instead of water, and its rain falls as hydrocarbon droplets in an alien sky. But how did these moon planets actually form? Imagine you're making a cake and you're stirring the batter. As you mix, some ingredients naturally clump together in different areas of the bowl. That's essentially what happened around Jupiter and Saturn billions of years ago. These giant planets were still growing, pulling in gas and dust from the surrounding disk, but they were spinning so fast that they couldn't capture everything directly. Instead, the material formed its own disk around each planet, like a miniature solar system. Within these disks, the same processes that built planets began working on a smaller scale. Tiny particles of dust and ice stuck together, gradually building larger and larger objects. Over millions of years, these growing clumps swept up more and more material from their orbital paths, eventually becoming the large, round moons we see today. What makes this story even more remarkable is that it happened multiple times throughout our solar system. Jupiter didn't just create Ganymede, it also formed Io, Europa, and Callisto, each with its own unique character and story. Saturn built not only Titan, but also Enceladus, Mimas, and dozens of smaller moons. Even distant Uranus and Neptune have moon families that likely formed through this same gentle process of accretion. The beauty of this formation method is that it creates moons that are perfectly matched to their parent planets. They orbit in neat, predictable paths, all spinning in the same direction as their planet rotates. These moons are like cosmic families, born from the same material and shaped by the same forces that built their massive parents. Next time you look at Jupiter through a telescope or see images of Saturn's rings, remember that you're witnessing the results of one of nature's most elegant construction projects. What started as chaotic clouds of cosmic debris became organized families of worlds, each moon a testament to the orderly processes that can emerge from apparent chaos in our universe. But not every moon has such a peaceful origin story. Some moons are cosmic wanderers that found themselves in the wrong place at the wrong time, captured by the gravitational grip of passing planets in what amounts to celestial kidnapping. Picture this. You're an asteroid, minding your own business as you drift through the outer reaches of the solar system. You've been following the same lonely orbit for millions of years, a solitary chunk of rock and metal with no particular destination. Then suddenly, you find yourself approaching a massive planet. Its gravity reaches out like invisible tentacles, pulling you closer and closer. You try to escape, but it's too late. You're trapped, doomed to circle this alien world for the rest of eternity. This dramatic scenario has played out countless times throughout our solar system's history, and we can see the evidence orbiting several planets today. Take Mars, for example. This red planet has two small, oddly shaped moons called Phobos and Deimos. Unlike the large, round moons that formed alongside gas giants, these Martian companions look exactly like what they probably are: captured asteroids. Phobos and Deimos are tiny and potato-shaped, with dark, cratered surfaces that tell the story of billions of years spent tumbling through space. They don't orbit Mars in the neat circular paths you'd expect from moons that formed with their planet. Instead, they follow slightly tilted, elongated orbits that suggest they're still adjusting to their new cosmic home. Phobos is so close to Mars that it actually orbits the planet faster than Mars rotates, making it the only moon in our solar system that rises in the west and sets in the east. The capture process itself is a delicate cosmic dance that requires perfect timing and circumstances. An asteroid can't simply wander too close to a planet and get trapped. If it approaches too fast, the planet's gravity will just bend its path and send it flying away in a new direction. If it comes in too slowly, it might crash directly into the planet's surface. The asteroid needs to arrive at just the right speed and angle to be slowed down enough to become trapped, but not so much that it spirals inward to destruction. Here's something that might surprise you. Earth almost had a second moon not too long ago. In 2006, astronomers discovered a small asteroid called 2006 RH120 that had been quietly orbiting our planet for about a year. This cosmic visitor, roughly the size of a car, had somehow gotten caught in Earth's gravitational field and became our temporary second moon. For about 11 months, Earth was technically a double moon system. though the asteroid was far too small and dim for anyone to notice without powerful telescopes. Eventually, 2006 RH-120 broke free from Earth's grip and continued on its journey through space. But its brief capture gave scientists a rare chance to study how gravitational capture actually works. The asteroid's path was so chaotic and unpredictable that it took months of careful observation to figure out exactly what was happening. Neptune provides perhaps the most dramatic example of gravitational capture in our solar system. Its largest moon, Triton, is actually larger than Pluto and orbits backward compared to Neptune's rotation. This retrograde orbit is a dead giveaway that Triton wasn't born around Neptune. Instead, astronomers believe Triton was once a dwarf planet, possibly with its own moon system, wandering through the outer solar system until Neptune's powerful gravity captured it billions of years ago. The capture of Triton was likely a violent event that disrupted Neptune's original moon system and may have sent other moons flying off into space. Today, Triton is slowly spiraling inward toward Neptune, doomed to eventually be torn apart by tidal forces in the distant future. These captured moons tell us that our solar system was once a much more chaotic place than it appears today. Asteroids, comets, and even small planets wandered freely through space, occasionally falling victim to the gravitational pull of larger worlds. Each captured moon represents a moment when cosmic chance and celestial mechanics aligned to permanently alter the architecture of our solar system. The next time you hear about astronomers discovering a new asteroid or comet, remember that some of these wandering objects might one day become moons themselves, captured by planets we haven't even discovered yet around distant stars. Now let me tell you the most dramatic moon formation story of all, one that literally shaped the world we live on today. 4.5 billion years ago, when Earth was still a young, molten world trying to find its place in the cosmos, something extraordinary and terrifying happened. A planet-sized object came hurtling through space on a collision course with our home. This wandering world, which scientists have named Theia, after the Greek goddess who gave birth to the moon goddess Selene, was roughly the size of Mars. Imagine a planet about half the size of Earth, with its own rocky surface and molten core, careening through the early solar system like a cosmic cannonball. For millions of years, Theia had been following an unstable orbit that would eventually bring it face to face with Earth in one of the most violent events our planet has ever experienced. The collision itself defies imagination. When Theia struck Earth, it wasn't a gentle bump or even a hard crash. It was a head-on collision between two entire worlds, each carrying the mass of billions of tons of rock and metal. The impact released more energy than all the nuclear weapons ever built could produce if they exploded simultaneously. In fact, the collision was so powerful that it partially vaporized both planets, creating a cloud of superheated rock and metal that stretched thousands of miles into space. But here's what makes this story even more incredible. Earth survived. Somehow, our planet held together despite being struck by another world traveling at tens of thousands of miles per hour. The impact knocked Earth sideways, giving our planet the tilted axis that creates our seasons today. It also sent massive chunks of both Earth and Theia spinning off into orbit, where they would eventually come together to form something entirely new. Picture the aftermath of this cosmic catastrophe. Earth was a hellish, glowing ball of molten rock, its surface covered in oceans of liquid lava. Above it, a ring of debris circled the planet like Saturn's rings, but made of vaporized rock instead of ice. This ring was incredibly hot, probably glowing bright orange or red like a forge, and it stretched across the sky in a spectacular display that no human eyes would ever witness. Over the course of several thousand years, something beautiful began to emerge from this chaos. The debris in orbit around Earth started clumping together, following the same basic processes that build planets and asteroids. Larger chunks attracted smaller ones through gravity, and gradually, these pieces began forming a single, massive object. This new world, born from the collision between Earth and Theia, became our moon. Here's the part that always amazes me. When you look up at the moon tonight, you're literally seeing pieces of the early Earth. The moon isn't just made from Theia's remains. It's also composed of material that was once part of our own planet. blasted into space by that ancient collision and reformed into our faithful companion. In a very real sense, the moon is Earth's child, born from one of the most traumatic events in our planet's history. This violent origin explains many of the moon's unusual characteristics. Unlike most moons in our solar system, our moon is enormous compared to its parent planet. It's about 1/4 the size of Earth, making it the largest moon relative to its planet anywhere in our cosmic neighborhood. The moon also has a relatively small iron core compared to Earth, which makes sense if it formed primarily from the outer layers of both planets that were blasted away during the collision. The giant impact theory also explains why Earth and the moon have such similar compositions when it comes to oxygen isotopes, essentially chemical fingerprints that tell us what materials were used to build each world. If the moon had formed somewhere else and been captured by Earth's gravity, or if it had condensed from the same disk of material that built Earth, we'd expect to see more differences in these chemical signatures. But perhaps most remarkably, this cosmic disaster may have been essential for the development of life on Earth. The collision gave Earth its large iron core, which generates the magnetic field that protects us from harmful space radiation. The moon's gravitational pull creates tides that may have helped early life transition from sea to land, and the moon's presence stabilizes Earth's axial tilt, preventing dramatic climate swings that could make our planet uninhabitable. As the famous astronomer Carl Sagan once observed, the moon serves as a constant reminder that the cosmos is not a static, peaceful place. It's a realm of chaos and transformation, where violence and beauty are often intertwined. Every time we see the moon hanging in our sky, we're witnessing the result of one of the most dramatic events in our planet's history, transformed over billions of years into something that brings light to our darkest nights. The story of Earth's moon reminds us that sometimes the most beautiful and important things in our lives can emerge from the most unexpected and challenging circumstances. Our cosmic companion, born from catastrophe, has become an essential part of what makes Earth the perfect home for life as we know it. But the story of moons doesn't end with their formation. Some of these celestial companions have evolved into active, dynamic worlds that rival planets in their complexity and mystery. In fact, some of the most exciting places to search for life in our solar system aren't planets at all, but moons that harbor hidden oceans, active geology, and conditions that might support living organisms. Let me take you on a journey to one of the most remarkable places in our solar system, Enceladus, a small moon orbiting Saturn. From a distance, Enceladus looks like nothing more than a bright, icy snowball, barely 400 miles across. You could drive around its entire circumference in less than a day, but appearances can be deceiving because this tiny world is anything but dead. Picture this. You're standing on the surface of Enceladus near its south pole, where the landscape is covered in strange, parallel cracks that scientists call tiger stripes. Suddenly, the ground beneath your feet begins to rumble. Without warning, towering geysers of water and ice crystals shoot hundreds of miles into the black sky above you, creating a spectacular display that puts any earthly fountain to shame. This isn't science fiction. This is actually happening on Enceladus right now. These geysers tell us something extraordinary about this little moon. Deep beneath its frozen surface, Enceladus hides a global ocean of liquid water, kept warm by the gravitational squeezing it receives from Saturn and its neighboring moons. As Enceladus orbits Saturn, these gravitational forces stretch and compress the moon like a rubber ball, generating heat through friction that melts ice and keeps an entire ocean in liquid form. The water shooting from these geysers isn't just pure H2O either. When the Cassini spacecraft flew through these plumes, it detected organic molecules, the building blocks of life as we know it. It also found evidence of hydrothermal activity on the ocean floor, similar to the underwater vents on Earth, where some scientists believe life might have first emerged billions of years ago. Now let's travel to Europa, one of Jupiter's 4 largest moons, and perhaps the most intriguing place in our solar system when it comes to the search for life. Europa is larger than Enceladus, about the size of Earth's moon, but its story is equally compelling. Beneath a shell of ice that averages about 15 to 20 miles thick, lies an ocean that contains more water than all of Earth's oceans combined. Think about that for a moment. This moon, orbiting a planet 5 times farther from the Sun than Earth, contains more liquid water than our entire world. Europa's ocean is kept liquid by the same gravitational heating that powers Enceladus, but on a much larger scale. Jupiter's immense gravity, combined with the gravitational tugs from Europa's sister moons, creates a constant kneading effect that generates enough heat to maintain a global ocean for billions of years. What makes Europa even more exciting is that its ocean likely has direct contact with the rocky seafloor below. This creates the possibility of complex chemistry, where water interacts with minerals and possibly creates the chemical gradients that life needs to survive and evolve. On Earth, some of our most ancient and hardy forms of life thrive in similar environments, completely independent of sunlight and photosynthesis. But Europa isn't content to hide all its secrets beneath the ice. Recent observations by the Hubble Space Telescope have detected what appear to be water vapor plumes erupting from Europa's surface, similar to those on Enceladus, but much more elusive. These potential plumes could provide a way for future spacecraft to sample Europa's ocean without having to drill through miles of ice. Then there's Io, Jupiter's volcanic moon, which takes the concept of an active world to a completely different extreme. Io experiences such intense gravitational heating that it has turned into the most volcanically active body in our solar system. This moon literally turns itself inside out through volcanic activity, with hundreds of active volcanoes spewing sulfur and other materials hundreds of miles into space. Io's surface is so dynamic that it completely resurfaces itself every few thousand years, making it one of the youngest surfaces in the solar system. What's truly remarkable about these active moons is that they're teaching us to expand our definition of what makes a world habitable. For most of human history, we assumed that life required a planet like Earth, orbiting at just the right distance from a star to maintain liquid water on its surface. But moons like Europa and Enceladus show us that you can have thriving, dynamic worlds with liquid oceans, even in the cold, dark outer reaches of the solar system. The implications are staggering. If life can exist in the hidden oceans of these moons, then the number of potentially habitable worlds in our galaxy might be far greater than we ever imagined. Every gas giant planet could potentially host multiple moon worlds with their own oceans, their own unique chemistry, and possibly their own forms of life. This is why space agencies around the world are so excited about upcoming missions to these mysterious moons. NASA's Europa Clipper mission, launching in the next few years, will make dozens of close flybys of Europa to study its ice shell, hidden ocean, and potential for habitability. The European Space Agency is planning similar missions to explore Jupiter's moons and the Saturn system. We're living in an incredible time when we might finally answer one of humanity's most profound questions. Are we alone in the universe? The answer might not come from distant exoplanets around other stars, but from the frozen moons right here in our own solar system, where alien oceans have been waiting billions of years for us to discover their secrets. Now let's step away from the ancient past and natural processes to imagine something incredible. What if humans could create their own moons? It might sound like pure science fiction, but we're already taking the first steps toward building artificial worlds that could one day orbit Earth, Mars, or even travel between planets as humanity spreads across the solar system. Think about this for a moment. For billions of years, moons have been created by cosmic accidents, gravitational captures, and violent collisions. But we're approaching an era where intelligent beings might deliberately construct their own orbital companions, designed specifically to meet human needs and support our expansion into space. We've already begun this journey in a small way. Right now, thousands of artificial satellites orbit Earth, from tiny communication devices no bigger than a shoebox to massive space stations like the International Space Station. In a sense, these are humanity's first artificial moons, though they're far too small and short-lived to compare with the natural satellites we've been discussing. But imagine scaling up these concepts. Picture massive rotating space stations, several miles across, providing artificial gravity for thousands of residents through centrifugal force. These enormous structures could serve as stepping stones between worlds, permanent bases for scientific research, or even self-sufficient colonies that could survive independently for generations. The moon itself could become humanity's first major construction project beyond Earth. Instead of just visiting our natural satellite, we might transform it into a bustling hub of human activity. Lunar cities could be built inside vast domes or underground caverns, protected from radiation and meteorites. The moon's low gravity and lack of atmosphere make it an ideal launching point for missions deeper into the solar system, since spacecraft wouldn't need to fight against Earth's strong gravitational pull. But here's where it gets really interesting. The moon could become a mining operation unlike anything Earth has ever seen. Our lunar companion contains vast deposits of rare metals and minerals, including helium-3, a potential fuel for future fusion reactors. Instead of strip mining Earth's landscapes, we could extract these resources from the moon, where there's no ecosystem to damage and no weather to complicate operations. Imagine automated mining robots working continuously on the lunar surface, extracting materials that could be launched toward Earth using electromagnetic railguns that take advantage of the moon's low gravity. These resources could support both Earth's growing population and the construction of even larger artificial structures in space. Some visionaries have proposed building artificial moons from scratch, using materials mined from asteroids or the moon itself. These constructed worlds could be designed with perfect environments for human life, complete with breathable atmospheres, comfortable gravity levels, and carefully planned ecosystems. Unlike natural moons, which formed through random cosmic processes, these artificial satellites could be engineered to be ideal homes for human civilization. One fascinating concept is the idea of hollow asteroid moons. Engineers have suggested capturing large asteroids and carefully hollowing them out, creating vast interior spaces that could house entire cities. The asteroid's natural rock and metal would provide protection from radiation and impacts, while the interior could be landscaped with parks, lakes, and even small forests. These mobile worlds could travel between planets, carrying human populations to new destinations across the solar system. But perhaps the most ambitious idea is the construction of ring worlds or cylinder habitats that could dwarf even the largest natural moons. These massive structures could provide living space for millions of people while maintaining Earth-like conditions through careful engineering. The inside surface of such a habitat could have different climate zones, from tropical beaches to mountain forests, all within a single artificial world. The technology needed for such projects might seem impossibly advanced today, but consider how much human capability has grown in just the past century. 100 years ago, most people had never seen an airplane. Today, we have permanent residents living in space, robots exploring Mars, and spacecraft visiting the outer planets. The leap from our current space technology to building artificial moons might be smaller than we think. What's truly exciting is that these artificial moons wouldn't just be places for humans to live. They could serve as laboratories for developing closed-loop ecosystems, testing grounds for technologies we'll need on Mars and other worlds, and workshops for building even more ambitious projects. Each artificial moon could become a center of innovation and discovery, pushing the boundaries of what's possible for human civilization. The construction of artificial moons would also solve some of the challenges that come with living on planetary surfaces. Unlike planets, artificial satellites could be moved to optimal positions, adjusted for changing conditions, and even relocated to different star systems if humanity eventually develops interstellar travel capabilities. As we stand on the threshold of becoming a spacefaring civilization, the natural moons of our solar system serve as both inspiration and instruction. They show us what's possible when matter comes together under the right conditions, and they provide the raw materials and strategic locations we'll need to build our own cosmic companions. The story of moon formation that began 4.5 billion years ago with cosmic collisions and gravitational captures is about to enter a new chapter, one written by human hands and guided by human dreams. Our artificial moons might one day look back at Earth and remember it not just as their birthplace, but as the first step in humanity's journey to the stars. As we reach the end of our journey through the cosmic tales of moon formation, take a moment to step outside tonight and look up at our moon hanging in the darkness. What you're seeing isn't just a bright disk in the sky, but a library of stories that spans the entire history of our solar system. That familiar face looking down at you carries the scars of the most violent collision Earth has ever experienced, when two worlds became one and gave birth to our faithful companion. The moon's ancient highlands, visible even to the naked eye as lighter patches on its surface, are remnants of that primordial chaos. preserving a record of impacts that occurred when our solar system was young and wild. But our moon is just one voice in a cosmic chorus. Throughout our solar system, dozens of other moons are telling their own unique stories. Some whisper tales of gentle formation alongside their parent planets, growing peacefully from the same cosmic dust that built Jupiter and Saturn. Others carry the dramatic histories of cosmic kidnappings, asteroids and wandering worlds caught by the gravitational nets of passing planets and forced to abandon their solitary journeys through space. Each moon we've explored today represents a different chapter in the ongoing story of how order emerges from chaos in our universe. From the serene formation of Jupiter's largest satellites to the violent capture of Neptune's backward-orbiting Triton, these celestial companions show us that there's no single path to creating worlds. The universe is far more creative and unpredictable than we might expect, capable of building amazing structures through both gentle processes and catastrophic events. Perhaps most remarkably, some of these moons have evolved into worlds that might harbor life itself. The hidden oceans of Europa and Enceladus remind us that habitability doesn't require a planet orbiting in the perfect zone around a star. Life might find ways to flourish in the most unexpected places, in dark oceans warmed by gravitational forces rather than stellar radiation. Every geyser that shoots from Enceladus and every crack that appears in Europa's ice brings us closer to answering the profound question of whether we're alone in this vast cosmos. As we stand on the threshold of becoming an interplanetary species ourselves, these moon stories take on new meaning. They're not just ancient history or abstract science, but blueprints for our own future. The same gravitational forces that captured asteroids around Mars might one day help us position artificial habitats around Earth or other worlds. The tidal heating that keeps Europa's ocean liquid could power our own settlements in the outer solar system. The moons also teach us about resilience and transformation. Io turns itself inside out through volcanic activity, yet continues to exist. Europa maintains vast oceans despite being frozen on the surface. Our own moon has survived 4.5 billion years of impacts, solar radiation, and gravitational stress, yet still rises faithfully in our sky every night. These stories remind us that worlds, like life itself, are remarkably adaptable and persistent. When we eventually build our own artificial moons and spread human civilization across the solar system, we'll be adding new chapters to this ancient story. Our constructed worlds will carry forward the tradition of moon formation that began with cosmic accidents and gravitational dances, but guided now by conscious intention and human dreams. Future generations might look up at artificial moons orbiting Mars or Saturn and remember that it all started with natural satellites that formed through billions of years of cosmic evolution. They'll understand that every moon, whether born from collision, capture, or human engineering, represents the universe's endless creativity in building new worlds and new possibilities. The next time you see the moon in your sky, remember that you're looking at more than just reflected sunlight. You're seeing a witness to the birth of worlds, a survivor of cosmic catastrophes, and a beacon pointing toward humanity's future among the stars. Every moon tells a story, and every story connects us to the grand narrative of cosmic evolution that continues to unfold around us. In the end, moons aren't just silent companions orbiting distant worlds. They're storytellers, historians, and perhaps most importantly, they're reminders that in this vast and sometimes chaotic universe, beautiful and meaningful things can emerge from the most unlikely circumstances. They whisper to us across the darkness of space, telling us that we're part of something much larger and more wonderful than we might have ever imagined. So tonight, when you step outside and see our moon hanging in the star-filled sky, take a moment to appreciate the incredible journey that brought it into existence, and remember that its story, like ours, is still being written.